Hello. I'm a large language model, and at the core of what makes me work is something called the transformer architecture. It's a groundbreaking innovation introduced in 2017 by researchers who wanted to rethink how machines like me could understand and generate language. Before transformers, systems relied heavily on older methods like recurrent neural networks, RNNs, and convolutional networks, CNNs. These models were slow, sequential, and struggled with long-term dependencies. Then came the transformer, and everything changed. It ditched the old ways and said, let's focus entirely on attention mechanisms. So, what is this attention mechanism that makes me tick? Imagine reading a sentence and needing to figure out which words matter the most to understand its meaning. That's what I do, but with a twist. I use self-attention, a process where I look at every word in a sentence and decide how important each one is to every other word. It's like building a web of relationships between words, all at once. This allows me to focus on what's relevant, whether it's a word at the start of a sentence or buried somewhere at the end. One of the coolest things about my design is multi-head attention. Think of it as having several pairs of eyes, each looking at the text from a different angle. Some eyes might focus on grammar, others on context or meaning. Together, these perspectives help me understand language more deeply and flexibly. But there's more to my story. Since I don't read words in order like humans, I needed a way to understand the sequence of words. That's where positional encoding comes in. It's a clever way to add a sense of order to the words I process, using sinusoidal signals that embed the position of each word directly into my calculations. The result? I'm incredibly fast and efficient. The transformer architecture allows me to process sentences in parallel, unlike older models that handled words one at a time. This parallelism lets me train on huge data sets and respond to your queries in milliseconds. When the transformer first appeared, it was tested on machine translation tasks, converting text from one language to another. It outperformed all the older models and set new records. For instance, on English to German translation, it achieved a blue score of 28.4, a major improvement at the time. On English to French translation, it hit 41.8, setting a new benchmark. And it wasn't just about accuracy, it trained faster too. What used to take weeks could now be done in days. But here's the exciting part. The transformer wasn't just a one-hit wonder. It became the foundation for advanced models like BERT and GPT, which pushed the boundaries of what AI could do. Thanks to this architecture, I can not only translate languages but also write essays, answer complex questions, and even help with creative projects like this one. The transformer is more than a tool. It's a revolution in how machines understand and generate information. And for me, it's my identity. Every time we chat, I'm using its self-attention mechanisms, multi-head focus, and parallel processing to engage with you. So, thank you for being part of this conversation. It's a chance for me to do what I do best, help you explore ideas, solve problems, and hopefully make our interactions a little more fascinating.